started. The lesson that we started yesterday, we talked about the warm-up already, but I just want to bring your attention to the fact that towards the bottom, when you are solving equations that involve exponents, okay, sorry. Will, yeah. Will, this is your laptop. Okay. All right.
I need the loaner back.
Oh, you need the paper?
The loaner.
Oh, okay. Yeah. All right, so when you're solving equations that involve exponents, and so here we divide out that coefficient of 2 from both sides, and so to undo that square, we have to take the square root. So the thing to remember is that when you are solving, if you take the square root of both sides, there's actually a positive and a negative answer to that, because what you're actually saying is what number, when I square it, gives me 81, and both positive and negative 9 do that. So a thing to keep in mind that as we're working today, whenever we use the square root, we're going to have to remember there are two possible answers, and that's actually also going to be true for any sort of even root that we have. So square roots, fourth roots, sixth roots, whenever I solve and I do that on both sides, I'm going to have to put that plus minus in front, and I'll kind of show you when we do some examples. Yeah? Right, exactly, because only 2 times 2 times 2 gives you positive 8. Yeah, the cube root of negative 8 would be negative 2 times negative 2 times negative 2. All right, so we're going to go ahead and start to solve some equations that have both radicals and exponents, and so the idea is that they'll just have ones that are like cube roots and fourth roots and stuff as well. When we're solving an equation, no matter what type of equation it is, we're doing order of operations backwards. So you probably learned order of operations as PEMDAS or GEMDAS. So if we're going backwards, it would look like SAD MEG instead. So it would be adding and subtracting first, then multiplying and dividing, then dealing with exponents and grouping symbols. Gentlemen in the back, can you be quiet? And we're going to do that to get the radical by itself. Once we have the radical by itself, we'll just identify what kind of radical it is. We'll look at the index to see, is it a square root, is it a cube root, or we can see what kind of root it is. And so to undo that root, we will raise both sides of the equation to that index or root as an exponent. So if we're trying to undo a square root, we would square both sides. If we're trying to undo a cube root, we would cube both sides. Once we've done that, we'll just continue to solve to get our variable by itself. And a thing that will come up is that it's possible that when you're solving something that originally starts with some sort of radical in it, you might get a number that is a solution, but when you plug it back in, it doesn't actually work. So checking your answers, plugging them back in, is going to be important here. So anytime my equation starts with a radical in it, I'm going to have to plug back in just to make sure the solutions work. Sometimes I get one solution, sometimes I get two solutions, and sometimes both of them don't work, one of them works, none of them work. So an extraneous solution is just the name we give to a solution that doesn't actually work. And so I would cross it off if it doesn't work. And we'll see an example of that. So the thing to get used to here is that when you're solving these in your mind or using a highlighter or a pencil or something, you just want to kind of identify what am I trying to get by itself. So it's anything that is with the radical. So that tells me I'm going to have to get rid of this plus 5 first. And if I look at the next one, the only thing that is the radical is that. So I'd have to get rid of this plus 5 and that 3. And so we'll kind of talk about how to do that. So if I'm trying to isolate this radical, I'm going to start by subtracting 5 from both sides. And then in my head, I would look at this and say, okay, the opposite of taking the fourth root of something is going to be raising it to the power of 4. In the same way that the opposite of taking the square root of something is squaring it, raising it to the power of 2. So taking the fourth root and raising something to the power of 4, those will undo each other. So I'll just be left with that 3x. And then 1 to the 4th power is just 1, exactly. All right, so then I'd go through and say, to get x by itself, I'm going to need to divide. So I got a solution of 1/3. But like I said, with radicals, it is possible to get a solution that when I plug it in doesn't really work. So we're just going to go through how do you check an answer. So I would go back and I would write my original equation, but I'm going to replace x with the x value that I got of 1/3. All right. So one thing I noticed last year when I was teaching this is that people, when they were doing their check, they started treating it like an equation and they subtracted 5 from both sides, that kind of thing. I only have numbers here. So if I have just numbers, I'm just using order of operations. What I'm going to do is I'm going to simplify this entire side using order of operations and see, does it actually equal 6? That's the only way I'll be able to know if that is a correct solution. So it's only when we have variables that we're moving things across the equal sign. Here, when I'm checking, I'm just simplifying using order of operations to see that it does work. So if I were looking at this, I would say, all right, I'm going to start inside grouping symbols. So I'm going to work inside of here, and I'm going to say that 3 times 1/3, I know that gives me 1. And then I would say, all right, I still haven't finished this grouping symbol. The 4th root of 1 is just 1. And now I'd be combining these together, and I can see that I do get a solution that works. So when you're solving, you're moving things across the equal sign. When you're checking, you're not. You're leaving it to verify that it does actually equal that amount. Questions about that? Okay. So here's my radical. I can see that it's a square root, but there are lots of extra outside things that I need to get rid of first. Could I have someone tell me what's one thing I might want to do first for this one? Yeah? Good. So I'm going to start by subtracting 5 from both sides because I know I should be doing adding or subtracting first. Okay. If I were to do this, why is that incorrect as a next step? Yeah. Good. So just be careful when you're working quickly. It's easy to make that kind of mistake. So you just want to say, oh, this is multiplication. So the only way I can undo it in that case is by what, Will? Yeah. So I'm going to divide both sides by 3. Yeah. So at this point, I look at the radical and say, all right, this is a square root. The only way to undo that is by squaring. Whatever I do to one side, I have to do to the other. So those will undo each other, and I'll have x plus 6, and then 3 squared will give me 9. So could you guys finish solving this one and then plug back in and just practice when we're checking, we're not moving things across the equal sign, we're just simplifying to see does it actually equal that amount. So you're going to finish solving and then check that one. If you need help with any of this, let me know. I'm just going to walk around.
Can you ask us to check on if we can mentally do it?
Yeah, you can mentally do it. Just make sure you are actually doing some sort of check, because if you, let's say that this was an extraneous solution, if you had it there as your answer, then this whole question would be wrong because you're saying that is the answer and it's not. Yeah. Alright, if there are ones from the warm-up that you still wanted to check, the key's on Blackboard, so you can look on there as well, and I'd be happy to help you during Warhawk time. Take a moment just to double-check, were you okay with finishing solving this equation? Were you able to check it and verify that it really does equal that it is a solution in that case? Okay. Alright, so I'm going to scooch this up because I know some people have started on the try it problems. And I'll keep walking around, so if you need help, just let me know. But even if you don't finish these completely, we'll keep solving equations that have radicals. So so we'll probably move on in a couple of minutes. And the key with these is just making sure that you're getting the radical by itself first, that you're isolating the radical. All right. So what are your questions for me about these types of equations? Anything so far that you're having trouble with? Okay. We'll kind of circle back to them in a little bit. But let's try some equations now where rather than radicals, we have exponents in them. So the process is still going to be the same. We're solving an equation. We're trying to get a variable by itself. So we use order of operations backwards. We do inverse operations. But this time we're trying to get the base, the thing that has the exponent by itself. And once we do, we'll identify the exponent to figure out how to undo it. So let's start trying one of these, and then we'll kind of fill in the rest as we get to those steps. So I'm going to find my base first. Notice that here, be careful, the only thing that has that exponent of 4 is actually the x. If both of them had that exponent of 4, they would be in parentheses to show that. So if you're working quickly, it's easy to think that 2 also has the exponent of 4, but it doesn't. So I would look at that and say, well, if I need to get that x to the 4th by itself, I'm going to have to start out by dividing out 2 from both sides. All right. So I've gotten the base by itself. I can see that my exponent is 4. So what would be one option for undoing this exponent of 4? Yeah, so taking like a 4th root, exactly. So I could take a 4th root of both sides. So, and I'll show that here. So, oops, sorry. So one way of doing this is just taking the 4th root of both sides. All right, so the one that Ryan just said is I'm taking the root of both sides that matches that exponent that would undo it. But there's another way that I can show a 4th root. So the other option, if I'm solving, is I could go ahead and just raise each side to what kind of exponent? What's another way of saying a 4th root with an exponent? Yeah. So these are equivalent to each other, taking a 4th root or using an exponent of 1/4. These will give me the exact same answer because they are the same thing. So that's your other option, is you can raise both sides of the equation to the reciprocal power. So instead of 4, the reciprocal would be 1/4. Okay. So whichever way you prefer, no matter what, these are going to undo each other, which leaves me with just x, same thing. When I multiply those together, that gives me just 1, so I have x to the first power. And then if I take the fourth root of 81, just to review how to do that using your calculator.
Square root twice.
Yeah, you could take the square root twice. Or if you go to your math menu, number 5 here will let you type in whatever sort of radical you want. So you could do that and just type in a 4 there. Or you could say, I know that 81, when I raise it to the 1/4 power, is going to also do a fourth root. And that'll give you your answer in the end. So no matter which way you do it, you're going to end up with a 3 is your answer. Questions about that? Okay. So we have continued to solve for the variable. We got it by itself. The only other thing that we need to be careful of, and it'll come up in this one that we just did, is whenever we take a square root, there's always 2 possible answers, and that's actually true for any sort of even root. So even roots would be things like square roots, fourth roots, sixth roots. Anytime that when I'm solving, I do that to both sides, I need to show that there's actually 2 potential answers to that. And the reason for that is if I double check now, because what I'm saying is what number when I raise it to the power of 4 gives me 81? Well, 3 does that, but -3 also does that. They both give me positive 81. So any sort of even root, when you do that on both sides, put that plus minus to remind yourself there are 2 answers there. So if it's not an even root, if this were a cube root, then it would just be 3. The answer would be 3. Because it's kind of like what Samara said earlier. When I take the cube root of 8, for example, it's just 2, because 2 times 2 times 2 is the only number that gives me positive 8 as an answer. If I do -2 times -2 times -2, that gives me a -8, not a positive 8. Other questions for me? Okay. So if I try the next one, I'm going to start by getting the base by itself. So everything that has this exponent of 3, I can see is in the parentheses here. So that base is actually this whole thing of x minus 2. But that tells me I need to get rid of anything outside and extra first. So I'm going to start by adding 4 to both sides. All right. So now that I've gotten the base by itself, how do I undo that exponent? Yeah. Okay. So it has an exponent of 2, so I'm going to be doing the square root in that case. And I can show it with a square root symbol, or I could do a power of 1/2, and that would mean the same thing. But these will cancel out, leaving me with just x minus 2. And then if I were to write this, why is that technically not correct?
This is an error, but you broke down to x minus 2, so the second power one is to the third power.
Oh my gosh, I'm sorry. Never mind then. So then, this would be a cube root. And Kathleen even said that. I'm crazy. Okay. So then the cube root of 64 is just 4 for that one. So I messed up. Since this is a cube root, it's an odd root, it wouldn't be plus minus. It's just if it's a square root, fourth root, or sixth root, like any sort of even root. All right, and the reason for that is if I double check, 4 to the third power is 64, but -4 to the third power is -64. So the only answer to the cube root of 64 is positive 4. And at this point, I'd be saying, all right, I'm trying to get x by itself, so I'm going to go ahead and add 2 to both sides. So in this case, x will equal 6. So I'm recording this lesson because I had some kids that were absent, so I'm just going to post it. All right. Questions for me about either of these? Okay. So take a couple minutes, see how far you can get on these try-it problems. We only have one more example after this that kind of brings everything together. It's a little bit of everything.
How do radicals define our answer?
Yeah. So if it's a radical you can't simplify, then yeah, you can do this radical. So technically the only number that's getting raised with 1 power is 4, and then it's multiple negative sign afterwards. So yes, but this means positive 3 and negative 3. So when you're subtracting 1, you have to do 4 times 1. Yes. Yeah. So
And so then what you're saying is if we're at this point, we look at the square root of both sides. Then this is positive. So anytime you're doing it,
For this one, I got my answer for the x equals to plus minus square root of 6, but only positive square root of 6. Alright, but square root of 6 squared would be 6, and then we turn it to negative 6, and negative 6 times negative 5 would be negative 30. Wait, no, it would be 30 plus 10, which equals 48.
So if I take the negative square root of 6 and I square it, if I multiply this to itself, does it make sense that a negative times a negative would give me a positive?
Wait, are you squaring?
So if you plug in, it would look like this. Negative 5, yeah.
Because you're not just squaring the square root of 6, you're squaring
The whole
negative
amount.
square root of 6.
There you go, exactly.
Okay, thank you.
Yep. For which ones? So you want to start by getting the base size. So the base is the thing of the exponent. So what is that? Can you circle it for me? Which? Okay, so that's what you need to be careful of. The base here is only the thing of the exponents. The base would just be that. So when you get rid of that, Alright, so take a moment just to double check how you did on these. So once again, be careful identifying the base. The base here is just that x. It's the only thing that's being squared. So you would need to subtract out that 10 first, and then also divide out that coefficient of negative 5. When you take the square root of both sides, you need to show that there's a positive and a negative answer to that. And since 6 doesn't simplify more as a radical, it would just be positive and negative square root of 6. For the next one, the only thing that's being raised to the power of 4 is everything in the parentheses there, so you have to get rid of that minus 5 first by adding it. To undo this this exponent of 4, you're taking the 4th root, and since that's an even root, that means there are two possible answers. So the 4th root of 256 is both positive 4 and negative 4. And the reason for that is if I double check, when I do 4 to the 4th power, it gives me positive 256, but negative 4 to the 4th power also gives me positive 256. Because if you think about it, if I have 4 negative 4s, anytime I multiply two of them together, a negative times a negative will give me a positive. So that's why I end up with a positive answer in the end. Right, so I'm at this point. So the thing to be careful of here is I have two answers that I need to do these operations with. So one option would be, if you think you're going to make a mistake, maybe you write it 2 times, where you're saying, I also know that 2x plus 1 equals negative 4, and I also know that it equals positive 4. So when I take away 1 from both sides, 1 from positive 4 is going to give me 3, and 1 from negative 4 gives me negative 5.
So why don't you just put that, you save that for the end?
So you can save it for the end, or you can write it out as 2 separate equations. So at this point here, I could say I know that 2x plus 1 equals a positive 4, but I also know that 2x plus 1 equals negative 4, and then solve them separately to get those two. Yep. Questions for me about that? Okay. Yep, I'll leave it there. Yeah.
So you would say, all right, we have to undo that radical, so we just square both sides. So before you square this, you're going to move the box for that.
Because you're doing 2x minus 1. All right, other questions for me about these two try-it problems? Okay. So our last example is just how to deal with ones that have both radicals and exponents. And you're going to see those as rational exponents, as fractions, where the top is the power and the bottom is the root. So same idea again. When I'm solving, I'm doing inverse operations. So order of operations backwards. I'd add or subtract first and so on. And that's going to be to get the base by itself. And once I have the base by itself, I'll figure out what kind of exponent it is so that I can undo it. So we'll start a problem, and once we get to this point, we'll talk about the other steps after that. So if I look at this first one here, the base is everything that has that exponent, and that's everything that's inside these parentheses here, is being raised to that power. So that tells me I have to get rid of that coefficient first. I'm going to have to divide by -3 to do that. And just be careful, a common mistake if you're working quickly is putting +3 on both sides and thinking that you've done it. This is multiplication, so you'd have to use division. All right, so now that I have the exponent by itself, if I want to undo this, what I can do is just raise both sides of the equation to the reciprocal as an exponent. So what I mean by that is, if I want to undo this exponent here of 2 over 5, if I raise it to the 5 over 2 power, it should cancel out. Because if I double check, when I multiply these fractions together, 2 times 5 is going to give me 10 on top, 5 times 2 will give me 10 on the bottom, and when I divide those, that gives me 1. So this would just be to the first power now. Sorry, say that again? So yeah, the way that this is right now, this is a... Right, so to undo this, I'd be doing a square root and raising it to the power of 5. So power and root. No, I did. Exponent of 5, root of 2. So these will cancel out, which will leave me with just x plus 21. But here's where you do need to be somewhat careful, is I'm going to continue to solve for the variable. But I need to remember that when I use even roots on both sides, that I'm going to have a positive and negative answer to that. So I would need to check what I did on both sides, which is in pink, and I would say, all right, I raised both sides to the power of 5, but I'm doing a square root. I'm doing an even root there, because the denominator is the root. So that tells me at this point, whatever answer I get to this, there should be 2 possible answers for that. Yep, so power of 5 and square root for both of them. So I'd look at 4. Correct, but so one of the exponent rules says that if I raise an exponent to an exponent, I multiply them together. So 2 times 5 gives me 10, and 5 times 2 also gives me 10, and 10 divided by 10 is just the first power. So this is to the first power now. So if I check 4, when I raise it to the power of 5, and I square root it, that gives me 32. So I have positive and negative 32 as an answer so far. Questions about that? Okay. So since I have 2 numbers here, I just need to remember that whenever I'm doing an operation, I'm doing it to both of them. If you think you're going to make a mistake, then maybe you just write out that you know that x plus 21 equals 32, but you also know that x plus 21 equals negative 32. And that way when you start to solve, you'll see that x equals 11 is one of the solutions. And then when I subtract 21 from both sides here, I'll get negative 53 for that. Questions for me?
Yeah, I don't understand how you got rid of the power of 5.
So here?
Yeah.
Okay. So to undo this exponent of 2, squaring something, the opposite of that would be doing the square root of, right? Does that make sense?
Yeah.
Okay. So when I do divided by 2 as my exponent, that's taking a square root. To undo this 5, that's a root, so I'd have to use an exponent of 5. This is an exponent of 5. So I'm just doing it all in one step instead of doing it in 2.
Oh, yeah, so it is a power.
Yeah.
I asked that.
So yeah, power of 5, root of 2. I'll come take a look at your paper. At this point, since we had an equation that technically had a radical in it, even though we aren't seeing it as a radical, this is a radical of 5, that tells us that we do need to double check and make sure that we don't get any extraneous solutions. So you'd want to plug back in and see, do 11 and negative 53, do they both work? Do they not work? Does only one of them work? All right, so take a little bit of time just to check these. Remember, when you're checking, you're not moving things across the equal sign. You're just simplifying to see, do both of these really give you an answer of negative 12 when you're working?
So to get rid of the power, an exponent of 2, I'm going to have to do the square root of, and the way of showing the square root is 1 over 2. So far. Because another way of writing a square root is with an exponent of 12. Okay. So the way that I would undo a radical of 5, the root of 5, is by raising it to the power. Power. So one of the things I talked about here was, and I showed it in yeah, so instead of doing it, we do 1 4 power. That's what these things are. All of these. That's our teaching now. They're all things. Where's going to be
All right. So you may have done your check differently. Maybe you did part of it in your head, but just double check that these should both work as solutions. So when I plug in, I'm just replacing the x value, and then I'm following order of operations. So here I'm doing what's inside the grouping symbol first, then I'm doing the exponent, and then from there I'm multiplying those together. So any questions about this one? If this is making sense to you, feel free to work ahead, but I'm going to keep showing these because I know that they can be kind of confusing. So I would look at the next one and say, all right, I need to isolate the base. The base is whatever has the exponent, and this is showing me that both the 4 and the x have that exponent of 1/6. So in that case, there's nothing extra to get rid of on the outside. So how do I undo an exponent of 1/6? Yeah. Good. And so the reciprocal would just be, yeah, so 6 over 1 and 6 divided by 1 is just a 6. All right. When I multiply these together, 1 times 6 gives me 6, and when I divide 6 by 6, that just gives me an exponent of 1 now. So all of this has an exponent of 1. If I do 2 to the 6th power, that's going to give me 64. So to get x completely by itself, I would be dividing out 4 from both sides. So I only do that if I'm taking an even root, and so I didn't take an even root, I raised to the power of 6. Yeah. If I were solving, if I had to use 1/6 to solve this, then that's when I would do that. Yeah. And if you check this one, if you plug it back in, this one does work. Let me do that. All right. So see how far you can get in the try-it problems. Make sure you are checking your answers. There will be one in here that's extraneous. And just be careful identifying your base. I'll put some highlights up here just as a kind of a reminder. Then you just cross it out. It's not actually a solution in that case. Okay, and I'll be right there.
Sure. So the only mistake I see is when I square this, it won't actually give me that. Squaring something equals to. So I should do 2x minus 1 times 2x minus 1. So you can use the box to do that, or you can just square it to do that. So 2x is 2x. So you would look at this and say, all right, I have a quadratic, so I'm going to work on moving everything over to one side of the equal sign and solving that quadratic. So you just got to think back to older units, how do we solve quadratics? And answer the question, I'll keep working my way over. Yeah, so you can use the box to do that, or you can just make a FOIL it out. So I think when you're done foiling, what you'll have is a quadratic. So you have to think back to like older units, how do you solve? So yeah, I don't know if this one's factorable, but it is. That would work for you to quadratic formula or graphing it. Yeah, any of that. Yes. Sorry.
So, for this one, was I right about saying plus or minus 1? Because 26, or negative 26 and negative 28 both work.
That one. Okay. The thing is though, I'm undoing this exponent.
Yeah.
He's squaring.
Yeah.
So I'm not taking the square root of the fourth root of both sides long.
Yeah.
So it's just the one answer for that.
Okay, but what if doesn't negative 28 work anyway?
I don't think it'll work because
Wait, because it's equal to 2. Okay.
and also if I plug it in, negative 28 plus 77 is negative 1. And this says this is the square root of. I can't take the square root of the second.
Alright, yeah.
So one I can equal that.
Okay, thank you.
So then you would look at this and say, this is a quadratic, so I can solve it using quadratic formula or factoring, graphing. But any of those that you do, you want to have all the terms of those as equal signs. Remember that sounds So this is a quadratic. If you look back at the quadratics, we will solve quadratics and factor them. Quadratic formula. Any of those will work.
Is that an arrangement?
Right, and so you can get back into this one here. Okay. Right, and since we got no resolution, this one there isn't. So let's remember what quiz switch with that. Do we write string as a quiz or do we write no solution?
Yeah, so I will talk about that now. All right, so take a moment just to see what you've done so far for these. Number 3, the solution that you end up getting is extraneous, because if you go back and plug it in, when I get to this point, taking the square root of 1 is not going to give me negative 1 as an answer. The square root of 1 is a positive 1. So what that tells you then is this solution that we got doesn't actually work, and since we had no other solutions to check, this equation would have no solutions. Let's say that you solved an equation and you got negative 26 as one of them and you got, I don't know, 50 as the other, and 50 did work. You would say that this is not a solution, it's extraneous, but this one is. So whenever you have an extraneous solution, don't include it. Cross it out. It's not actually a solution in that case. So for one like this, I got no other solutions from solving. If I did have another solution and it worked, then I would circle that one and say, that's my solution. Right, yeah, exactly. Yeah. It's whenever you are taking an even root on both sides. So when I did this here, I know it's hard to tell because I used an exponent that's a fraction, but power root, I did a square root on both sides. It's an even root, so I know that I'm going to have to do plus minus for my answer. If I did the 4th root of both sides or the 6th root of both sides, yeah. So when I'm checking an answer, I'm using order of operations to simplify. What'd you get for your grade? So start by doing what's in the So I would combine together negative 26 and 27 into 1. And then you're doing the exponent. So you go to the 1/2 power. Another thing is the square root of 1.
No, I have these ones.
This doesn't mean 1 times 1/2.
So I would also like
Power. So, which another way of saying it is the square root of 1.
Oh, my order something for me? No, come back. I need that. Give it to me. I'll die.
So I think
Isn't silencing that thing where you like that one split your brain to your partner?
It might be. I'm not sure. I really don't.
I'm so glad I didn't have to do that. It's like I would have given myself a